Hey folks, welcome to Buildfly Go. This is part 2 of our magnetometer test harness build videos. And in part 1, we covered all of the tools that I use, everything from sort of the cheaper generic tools that I find do a good job to the more expensive mil-spec branded tools that are used in the big avionics shops all out there. Coming up, we're going to be looking at the connector kits and what comes in a little connector kit from Garmin, right? Like the back shells, the pins, all of that kind of stuff. And then we're going to jump straight into building the harness, putting the pins on it, cutting the cable, dealing with the shields and all that kind of stuff. I don't go into a ton of detail on some of these tasks because Garmin has a series of videos that is really good that covers crimping stuff and solder shields and solder sleeves and things like that. So I urge you to go look at the Garmin videos. Garmin videos and documentation are key here, right? We're doing everything to the docs because the manufacturer has defined, how to do this, and they have tested all of this, and this is how we know it's good. So watch the Garmin videos, watch part 1 to see the tools that we're using, and here we go. Let's get started. So we're going to use Garmin connectors, terminators. So you're going to need one terminator for each side. And the connectors come in like a little baggie like this. This is just a 915 pin Garmin connector. And it's part of the installation kit. When you buy the GMU11 and you order the installation kit, it comes with this, which is the proper connector for the GMU11. It has the pins and everything. I can open one of these up. It has the pins and everything in here. It's just a lot of little baggies. All right, so there's the connector itself, and then there's a bunch of pin baggies for the different pins. There's a terminator, and then there's the back shell itself. So I'm not going to open a new one, only because this is a sort of a test harness for us, right? It's just to find the right spots for the magnetometer. But it's a harness that I have actually, when other people have asked me for, like, oh, do you have something like this? And it's like, well, I don't, but, I should just have it hanging around. We have a lot of airplanes in the area that are getting, like, G5s put in and things like that, and a lot of them tend to come to me for suggestions on things, and just having one of these handy would be nice to lend out to local airplane people. So, I have just pre-cut the wire here to size. It's about, I don't know, like 6 feet, maybe 6-7 feet. I've put it in sheathing just to protect it a little better, because this is the wire that's going to go from the G5 to the GMU11. Aviation wire, sheathing from the usual aviation stores, and I just printed a label for the end that's going to, sort of close off the sheathing to clean things up. I also cut down some wire for the power for the G5, and we're using the standard Garmin instruction sheets. I just printed this off the G5 installation manual for both of them. This first sheet has a wiring diagram, so it's got a G5, a GAD13, which we're not going to use in this case, and then a GMU11, and it just shows you the pins, right? This is 2-conductor shielded, and it's, shielded on this end. I'm sorry, the shield is drained on this end to the back shell, and again on this end to the back shell. So just 2-conductor, and it shows you that connected G5 circuit breaker number 22 wire and a ground, and here's the G5 circuit breaker number 22 wire as well. That's a 5 amp. It just gives you an idea of what that looks like. And then I also have the pinouts for both devices, the G5 pinout, just so I know where everything goes, and the GMU11 pinout, again, so I know where everything goes. Fairly simple stuff. This is a good starter thing for us to wire, because it's hard to break something. And I also have printed off in one of the first few sections of the wiring diagrams in the G3X installation manual. They have a breakdown of like all of the different things that you need when wiring a connector, and they also talk about the different options for how you're going to terminate shields. There's a few different options depending on how much space you have and things like that. I am going to do the quick, where is it? The quick term method, which is method B1, which is that. So depending on what you're doing, one is going to be right or the other is going to be better. Either one is fine. This is somebody else's quick term. This was a harness that I got from something that I chopped up, and I've been using the wire for practice stuff. You'll notice that this does not match what Garmin is doing. There's a couple of things that is different here. One of them is the drain is coming off of the back, and as you can see in the sheet, Garmin would like it to come out the front. Also, in this case, Garmin prefers that you use wire braid instead of a wire. And we're going to follow Garmin's instructions on here because they know what they're doing. There are many different ways of doing this. There's probably many rights and many wrongs, usually more wrongs than rights. But as we're doing the Garmin installation, we have chosen to follow the Garmin methods. Not to say that this is wrong, it's just a different way of doing it. But that's it. So I'll be building this harness, and you'll watch me do the whole thing. I'm not going to go into a ton of detail. I think I've already covered all of it, but you'll get to watch me put it together. Do watch the Garmin videos. They are very, very good, and they go into a lot of detail on terminations and shield drains and all that kind of stuff. Okay, here we go. Okay, so here's the wire already in the wire sheathing. Looking at my docs, this is the quick turn method. It's a back shell size 1, which is a 9-pin, which we can tell from here and also from there. And my quick turn max inches is 2 1/4, which, yeah, 2 1/4 is already a little tight, so we won't do any less than that. So 2 1/4. Again, follow Garmin's videos on this. Their videos are very, very good. Oh, this thing is sharp. So I have this little block, which I got from Stein, which is a good way of sort of holding this down. I haven't used this block much. I just got it recently, figured I would try it out. Yeah, maybe I will do this by hand, which is what I'm used to doing. Just a new tool, right? Just to figure that out. All right, I'm gonna leave about 1/4. Jeez, come on. What's going on here? There we go. Fold it over back of jacket for this one. So I'm just gonna pull this back. And we don't need that anymore. Okay. Let's find the right size here. I think it's a number 3, but let's see if a number 2 will fit. No, number 2 is too tight, so it is a number 3. Yep, that's the one. I want to tighten this up a little bit, just a tiny little bit. I've pre-cut these. Splay it out just a little bit, just so it sits right. You can buy these with the shield already in place. Okay, so I looked up the temperature to set the heat gun to, and for this heat gun, the HL2010, for the S01, it's 700F on LCD. So let's up this to 700. Try not to burn ourselves. How about that? I'm gonna put this up real quick. Just make sure this is inserted properly. Make sure this is good. It's centered. All right, let's do this. See the solder melting. Still see red indicator. There we go. And the red indicator is gone. This is going to be quite hot, so I'm not going to touch it. I'm going to do the other side real quick. So we'll speed this up because it's exactly the same as the other side. I'm just slicing open the insulator, pushing back the shield, cutting it to size, folding it back, getting a solder sleeve, fitting it over to place, putting the shield drain in place, and then heating it up to melt it down, keeping an eye on that indicator, that color, to make sure it no longer goes red, and then just inspecting. So this is a number 22. And let's grab some pins. And both sides are, just confirming, both sides are male on the devices, so the cable is female on both sides. And where's my crimper? Here's the crimper. This is number 22, so number 22 is a number 6. It's already set to 6. I always like to check that this is not too short, not too long. I'm gonna put that down and put this thing on because I can't see squat. It does feel like I need to take a tiny little bit off more. A little bit more off. I always feel like when I try and take a little bit more off, I take too much, which we're about to discover. Yep, just a tiny little bit too much. The spec says you can have, I believe, don't quote me on this, you want to double check, about 1/64 of wire showing past the thing. There it is. So insert, don't smoosh it, but hold it firm. There we go. Give it a yank. Looks good. All right, and the other one. like not enough. Yeah, not enough. Just a smidge more. Of course, looks like too much. Nope, that is actually just right. So, there we go. Okay, crimp, yank, looks good. Okay, this red one looks like it doesn't have quite enough showing. There we go. And it is obviously too long, so we're going to cut that down. And I'm just going to triple check this wire because it looks a little bigger than 22. Yeah, it's a 20. 20 is not necessary. Because this harness isn't going to go in an airplane. It's not. There's no real downside to going a little bit bigger. Don't go smaller for sure. Don't go smaller. Yeah, that looks fine. Okay, and I changed the wire size, so now I need to go change the setting on the. So for number 20, it's a 7. So I'm flipping that to 7. And there we go. Good, feels good. All right. And this black is just a smidge too long, so I'm just gonna cut it down. I did check the other side to make sure that there was lots on the other side. So here's number 20. That feels good. Yep, that looks great. We're still set for 7, which is number 20. Squish her down. Looks good. All right, so this wire looks pretty damn good. So let's take a peek. So this is going to be the pin out. I'm going to say this is the G5 side. Doesn't really matter, does it? Let's see. Pin 1 and 2 is pin 1 is high, pin 2 is low on both of them. So as long as we're good there. So high goes to high, low goes to low. So we're good there. Pin 1 and 2. And power is pin 7 on the G5 and pin 7 on the magnetometer. Ground is pin 9 on the G5 and pin 9 on the magnetometer. So it doesn't matter which side is which for this. So let's pin these up. This is the spot where you can release the smoke, right? So on the back of these, you can read, there's tiny little numbers. So 9 is this one on this side, and 9 is ground. So I'm going to push in the ground, and just confirming, pin 7 is power. Hi, Valentina. Yeah, pin 7 on the diagram is power, 7 or 8. We're going to go with 7. And just triple checking the number on the back here. Pin 7. So it's 9, 8, 7. 7 is power. And just checking the front. 9, 8, 7. It's really nice that Garmin provides these really high quality mil-spec connectors. I keep saying that, but I've used the cheap version of these and they're terrible. Okay, and there is a standard for the order in which you're supposed to put the colors of the wires, and I can never remember this, so I'm gonna look it up. All right, so here it is. It's mil-spec Mil-C 27500G, table 3A, has the wire color order. So wires 1 through 10, and the wire colors. So white is the first one, white blue, white orange, white green, white red, etc. So white is the first one. And I'm gonna keep life easy and say this is white, and then white blue. So pin 1 is white in this case. And I know that pin 1 is the one on the far left. Here we go. I always read it off of the connector because I'm super confused by these diagrams. I'm sure if I thought them through, they would start making sense, but I just like reading it on the connector, so I know I don't screw it up. Come on. All right, there we go. So that one is done. And I'm going to close this guy out just to make life easier. All right, and I'm just looking at where the strain relief is going to go. And there's not much wire there, so we're not going to use very much of the silicone tape. And you just want to wrap it there we go. So is that going to cover it? Yes, it does. Good. All right. And then these two. You make sure that the sharp part is not into the cable. And I'm just getting these started. I'm not going to yank on them quite yet. You don't want to crush these, right? Like you just want to... It's a strain relief, not a strain creator. Okay, how does that look? Just a tiny little turn there. Okay. That looks pretty good. I'm going to close this guy out because that looks correct. I'm going to there and there. This is a little snug. All right, and let's grab the proper size shield screw here. I've got a few different lengths in here just because I'm a big believer in washers and lock washers. And is that the right size? Yep, and it's a red one. Yep. Okay, so here it's going to get its own. So there's not a lot else going on here, so it's okay for me to cut that a little shorter. I think I can go a little shorter even. Of course, when you're doing one of the big connectors, right, like there's going to be a ton of stuff going on here. So you don't want to sell yourself short on the lengths. You don't want things to bunch up. Okay, it's going to go that way, so I want it in here. I want to make sure it shows through. Come on. Show through and crunch. Okay, that looks pretty good. A little tug. Looks good. Here's my wire, my screw with a lock washer. Let's tighten it down. Okay, nice and tight, and make sure it's not peeking through because you don't want it to cut into or short your other stuff. Okay, now here, I can heat shrink this down. All right, so I just want it to be, right, like I want it to cover the end to just clean things up, but I don't want it to cover the solder shield because I want to be able to see that, right? If I ever need to inspect this, I want to see where things are. Yeah, that looks good. There we go, nice and tight. Very nice. All right, that was one end. Easy enough. This end is exactly the same. All right, so we have it all pinned. I sort of sized the length of the shield and crimped that on there just to get that out of the way. And the one thing that's different on this side, right, is we're not going to connect the powers and grounds of the two devices together because those are actually, you know, they have to go to a battery or some sort of power source. So I have pre-cut wire here, and I'm going to use some little, just butt splices, nothing fancy. And I'm going to cut the power and ground back a little bit. To make this sane, I believe I am actually going to cut back the sheathing a little bit as well. Be very careful not to cut your wire here. Where is it? There's one more little snip I need to make somewhere. I have a Valentina here trying to make this video a little shaky. Go down, there you go. Okay, so I just cut this back so that I had a little bit of room to work with, right? So I'm going to snip these wires here, roughly, so that I can strip everything back and butt splice in a joint. This is going to make sense in just a minute. So what I'm doing is I am splicing in these other wires. Red and black. We're just going to strip everything down and strip these as well so that I can butt splice them in. All right, so let's grab the two reds. Are they the same length? No, I want to add a little bit more to this one. There we go, that's the same length. And I just want to slip them in just to make sure these are the correct length. Yes, that is correct. And I'm going to prep the squeezer, pre-squeeze just a little, just to hold it. There it is. Okay, so and I'm going to insert both of these on one end. Make sure they're showing the right amount. There we go, that looks good, feels good. Squeeze. All right. That's a good pull, good pull. And then I can squeeze the other end. Just want to make sure this is the right length. It looks like I need to take a little bit more off here. There we go. Same deal. Just want to make sure, follow the steps on how to do this, the butt splice manual. These are Pidge butt splices. I'm a big fan of, there we go, nice and tight. Big fan of using these in aviation. They've got little serrations in them so that they really grab wire. This does not look long enough. No, we need to take a little bit more off. A little bit more insulation off. I think as usual I took too much off there. These look the same, they do, good, okay. Okay, there, that looks good. There we go, that feels right. Nice and tight. Squeeze. Give it a pull. Okay, that feels good. Is that in the right spot? Not quite. There it is. That looks right. Okay, squeeze. All right. Okay, so finally, back to this. So, where are my goggles here? The older I get, the harder it is to see this stuff. So, 9 is the ground. Let's just make sure these are the right length still. Yes, they're good. 9 is the ground, so let's find number 9 here. There's number 9. 9 is ground. Okay, feels good. 7 is power 1. There's 7, power 1. Okay. And now back over to here. White is the first one. White is can high. Can high is number 1. Just push that in. There we go. These are not brand new connectors, so it's a little easier to push. On your brand new connectors, you want to be careful that you don't like squish the wire when you're pushing these in, right? Like do it carefully. If it's not going in easily by hand, use the pin tool, right? Like the pin tool will just push on the pin itself and not on the wire. Okay, got a little strip of silicone and just have an idea of where it's going to be. Okay. There it is. Looks like I got a little too much silicone there, but it doesn't hurt anything. Especially in a little connector like this that's not full, right? Like in a full connector, it can make it really bulky, but on this one it won't. Okay, that looks good. There we go, that feels better. All right, tighten it down. You're not gonna squish it. You're just looking to tighten. Yep, just until it's holding in place. There we go, that looks good, feels good. So again, Garmin has excellent videos on this process, on the assembling the connectors, on putting the shields on crimping everything, which is why I'm not going into crazy detail on any of this. Go watch the Garmin videos. I am just doing a end-to-end, right, like beginning to start. Let's just make a connector. All right, our shield. So pick one of these two. I'm gonna do this one. There it is. Make sure it doesn't twist on me when I'm tightening. There we go, that feels pretty good. All right, then back to here. I need to wipe this down so it's not confusing. Back to here. I'm just gonna shrink this down. I've readjusted the gun so that it's at the temperature for the sheathing and for the heat shrink, right? Like, you don't want to melt the sheathing. The sheathing temperature, melt temperature is definitely less than the solder sleeve temperature. So if you had this still on the solder sleeve temp, you would melt the sheathing, and you know, that's no good. All right, so here we go. We have a magnetometer, whoops, a magnetometer test harness. What I'm gonna do right now, you're gonna see, is I'm gonna get myself a breaker. And the reason I'm doing this now is, where's the load, line, and load? Okay, so line is here, is because I'm going to crimp onto the end of this. And I just want to see what size. There we go. That's the proper size. And strip this back. I think that needs a little more. There we go, that looks right. Yep, that looks right. All right. There we go. Okay. And onto the breaker we go. This way, when I grab this to plug it in, I already have a breaker right there. And then I just need, you know, a wire jump from here to the, I'm actually gonna keep that popped, a wire from here to the battery and here to the battery. Haven't figured out yet what battery I'm gonna use, probably a little portable power supply or something like that. Yeah, but part of the mess here. So here's what we're gonna do now. I'm going to make one of these messy, because this is our documentation for this harness. What I'm going to do is I'm going to mark the pins that we used. So can high is done, can low is done, power 1 is done, and ground is done. And the same on this side. So we know these wires are there. I'm going to be super crazy in this case and also mark it on here, and here, there, and there, there, and there. And we know that matches what we have here. Last thing I'm going to do before I plug this guy into anything is I am going to measure continuity for the power and grounds, because I want to make absolutely certain I don't have those flipped. Okay. And in continuity mode, yep. Okay, it bleeps. And just to make my life a little bit easier, whoops, I'm going to insert one of them in here. Okay, so pin 7, pin 7, and here again, pin 7. We're good, so power is good. Let's just check grounds real quick. And I might not have enough hands for this right now. All right, ground was pin 9, pin 9. We're good. Pin 9, pin 9. Looks good. Okay, so I know I am not going to fry anything because the pins are according to the manual for the power and ground. Now, the CAN bus might not work, right? I'm not going to test every single one of these pins. I have some confidence that I did it correctly, but I wanted to make sure that the crucial ones are correct. I do recommend, it sounds like a lot of work, but I do recommend you check that on your complete harness. We are going to do it on the big harness because all of this stuff is expensive. Okay, so I have the harness plugged in to the G5 and the GMU11. Notice that I have a terminator on each end because that's proper CAN bus design right there, terminator on each end of the bus. And I have the power and ground plugged into little power supply, which you can see over there. So let's start this up. I'm just going to push in the breaker and we'll see the G5 boot up. Everything's good, no smoke. Looks like the G5 have a slightly older software version, which is fine. We'll update that later. Okay, so it boots up, it's fine. Let's reboot this thing and start it up in config mode. So per the manual, I'm holding down, there we go. And I'm gonna do a couple of different things. I wanna look at the CAN bus standalone instrument. I want to look at the CAN bus error rate real quick, just to make sure that there's nothing wrong. Nope, looks fine. Wiggle the wire. No errors, okay. So back that out. Go back. Now, oops, back one more. And now I'm going to go into the magnetometer setup. And by default, magnetometer is disabled. I'm going to enable the magnetometer. Magnetometer status is not calibrated as expected. And I'm just going to set connectors to whatever, right? It doesn't, in this case, it doesn't matter. Because we're not going to actually calibrate the magnetometer. We're just doing a magnetometer interference test. So then interference test, I'm going to click there. It's going to ask me that I can exercise, flaps, lights, beacons, all that kind of stuff. Yeah, that you're in a position to do that. In the G3X manual, I believe in the G5 manual as well, there is a checklist that you can use. Just download the manual. There's a checklist that lets you put in the times for everything you do, right? Turn on the beacon, turn off the beacon, turn on the strobes, turn off the strobes, move the flaps, stop moving the flaps, and all that kind of stuff. You're going to step through every one of those items while this is running and jot down the time, so then you know if one of the things is what caused the problem. So let me start this and you'll see what I mean. So it starts, prepare the detailed sequence, yep, and hit the start button. And you'll see it's showing you magnetic deviation, the current time, and hit done when complete. So what I would do in this case is, let's actually move this, and you can see, yeah, you see the magnetic deviation peak as I'm moving something near it. So what you would be doing is you would have the GMU in the plane, in the location that you want to test. So for us, it would be on the first bulkhead, behind the baggage bulkhead, up high, right? There's a little bracket up there. I would place this there. Then I would run the interference test and start moving stuff, moving servos, turning on and off lights, things like that. Of course, in an experimental aircraft that's being built, you don't know, right? You don't have you can't turn on and off the lights yet, right? Like you're picking this location ahead of time. So talk to the community, figure out what works and what doesn't work, and go with there. We talked to avionics installers, big avionics shops, and also asked in the groups online, where people are putting them, and it seems that the location we picked is okay. We are, of course, going to do this anyway, right? Because we want to triple check that everything is fine. And of course, we're going to do it again once we have everything available, right? Like we can turn the lights on and off and things like that. But we're fairly confident that everything's going to be fine. But you can see in this case, right, because there's nothing here, nothing really moved. Worst case was 13% of limit at 0.13. Let's do this one more time, but this time I'm going to see if I can make it fail. What can I run over here that's... There we go. It's just, whatchamacallit, razor blades, or a box of razor blades. So fairly ferrous. And status is fail. Worst case was 999% of limit at 0.03. So not to put ferrous stuff around your magnetometer, and because otherwise you're going to have problems. Later on, you're going to calibrate, but we're not going to do this until the airplane is, doing taxi tests and things like that, right? Where you can spin the plane around to calibrate the magnetometer. What we're looking for is an interference test at this point. But yeah, so there it is. We have from wire, right, created, let me zoom this out, created the harness, put the connectors on, pinned everything on both sides, right? We're using a breaker, always use a breaker when doing any of this kind of stuff. Easy enough, and we'll keep this harness around for any other magnetometer tests that come up. There's always one that comes up in the community. But yeah, thank you for watching. This was a fun little build and gives you an idea of, how to go from start to finish on one simple little harness. We'll see you soon.